Good evening, everyone, to tonight's CIBSE webinar event. Tonight's webinar event is that of Prefabrication and MEP, presented tonight by Dan Hogan, Associate Director of Mace Group. And I better share my screen, I just realised, would make it much more informative. Dan Hogan, Associate Director of Mace Group, who will be presenting today on behalf of Mace, and Neil Vipior from Evo MEP. This presentation will run for just on an hour, and at the end we'll have a Q&A session. So please raise your hand, or more importantly, I'd say, post your questions and answers in the Q&A section, and I'll attend to them towards the back end of the presentation. But first, some first things to do with CIBSE. I would like first to acknowledge the traditional custodians of the land on which we meet, and pay my respects to their elders past, present and future. We stand today on the Dja Wurrung people land, and also acknowledge the traditional owners of country throughout Australia and recognise their continuing connection to land, waters and culture. We pay our respects to their elders past, present and emerging. I'd like to draw your attention to the upcoming 2021 CIBSE ANZ seminar series. This will be examining future trends in healthy building design and operation, presented virtually as five separate 2-hour sessions from the 7th of September through to the 5th of October. The 2021 CIBSE seminar series will examine future trends in healthy building design and operation. 10 experts from Australia, the US and UK, New Zealand will showcase the latest research and case studies in healthy building design and operation, from electrification of buildings to the best ventilation practices for safe, healthy workspaces. In addition, each of the 5 session dates includes a panel discussion, giving delegates the opportunity to get involved in discussions and Q&A sessions. This event will also deliver 10 hours of structured CIBSE CPD. Please visit cibse.org.au to see session information and to register for this event. Not yet enjoying the many benefits of CIBSE membership? Join today to gain access to the following knowledge products and services for 17 months. A monthly subscription to the leading building services magazine, the CIBSE Journal, worth approximately $120 New Zealand or $100 Australian. It provides unlimited digital access to over 950 built environment guides, publications and research reports. There's a 20% off CIBSE training with savings of up to $350 New Zealand or around $320 Australian. There's exclusive discounts on local and international events and recorded content, including over $70 off the 2021 CIBSE ANZ seminar series just previously described. There's guidance and discounts on upgrading to corporate membership grades with professional registration. Please take the time to scan this QR code that's in front of you now, so that it can take you directly to the application process. I would now like to draw your attention to the Connexus Recruitment for their support of CIBSE ANZ's annual program of technical events, and share a short video with you from Connexus, our sponsor. And that's our presentation from Connexus. I'd now like to hand over to Dan. So I'll stop sharing my screen. And if Dan Hogan can pick up the screen share, I'll now drop off my video and welcome. Thank you, Dan.
No problem. Thank
Over
you,
to you.
James. So good evening, everyone. Thank you very much for having me along tonight. So I wanted to run through slightly more high level. I think Neil will probably give a much more detail into some of the specific regions or specific MEP innovations, but I want to provide a bit more of a higher level overview. So innovation, the why. So we've got this review here that was conducted in the UK by McKinsey & Company, and effectively, market characteristics. We've got strong and cyclical custom demand, but highly bespoke in those demands. We've got complex nature of construction and logistics, high share of manual work, and low barriers to entry for the market. There's extensive local rules with lowest price tendering as well. So the dynamics that produce is a project-based approach to the building industry, highly fragmented ecosystem. So, contractors, subcontractors, consultants, subconsultants, misaligned contractual structures and incentives, and then obviously the use of contractors and temporary staff. And so the outcomes of that is that we've got lagging productivity as an industry. We've got really slow innovation and digitization of the industry. We've got low profits but high risks for everyone participating in that marketplace, and we've got low customer satisfaction. So the automotive industry is often used as the analogy. So effectively, what you can see here in the picture is an old Mark II Golf, obviously late 80s, early 90s, and VW effectively established that their vehicles were becoming more complex, more bespoke to themselves. And in 2012, they embarked upon their Mqb strategy. Their Mqb strategy was effectively a platform modular toolkit strategy. And it was the idea that at the standardization, the clever standardization of their vehicles across their entire portfolio could create, that choice and those different varieties for their customers. And this is effectively what it looks like. So you've got the platforms, which is the chassis effectively, and that works across your body design. So your hatchback, so your VW Golf is your Audi A3. Then you've got the modules that work across those vehicle classes, but also up into your saloons, down into your hatchbacks, etc. And then the toolkit strategies, which work across, from a Volkswagen to an Audi and up and down the vehicle classes as well. And I quite like the quote at the bottom here from Car Magazine, and effectively talking about it heralds a return to the basic principles of mass production, like the Ford production 100 years previously. Vehicles had got highly complex in the late 80s, early 90s, and VW did something about it to try and standardize that, but standardize it in a clever way. So this is a slide from Mace and how we go about that in the UK. So effectively, if you start on the left-hand side, we've got a standard design catalog, and then also you can get configuration tools, which is elements of parametric modeling. Then you get the two branches that kind of come off that. You've got your standardized components that you buy direct from your suppliers, and then they're shipped directly to your site. And then you've got the sub-assembly platforms, which is effectively your production lines. That's where you get all your raw materials delivered in. They're then assembled in such a fashion that's required for site, and then delivered to site and all constructed together. And then obviously the building is owned and operated by the client. But the important thing is that we get that feedback loop, and that feedback loop returns back into the configuration tool and into the design catalog to improve the knowledge there. So why are we doing this? And effectively, we're getting consistent quality, we're getting faster, reduced tolerances and safer. And I think those are really, the big focus points in Australia at the moment is those four key points there. The last three, with less waste, reduced deliveries and less embodied carbon, I think are going to become, a far greater imperative over time. Chairman of Lendlease was in the news earlier on in the week talking about how Lendlease will approach, this zero carbon direction, but implored the government to try and do a bit more in that space. And I think another thing that often gets overlooked is the certainty. So when we move to a manufacturer-based approach to construction, we get higher levels of certainty. You know, in the sector, we run high levels of contingency in cost and time. But when we get to a more sort of industrialized output, we can forecast that much better, and we can run skinnier contingencies. So just looking at a case study. So this project is a project called N06. It's a Mace development in East London. It's a residential development. And here's some of the sort of findings of what Mace have done here. It's constructed in a very similar way to Hickory Group, which I know are a Victorian-based business. So we had a 30% improvement on the program to the start of fit out. The productivity was far increased. So we were getting about £170 worth of productive work per hour versus £60 per hour on a traditional frame construction. We had far fewer resources on site. We had 75% reduction for off-site deliveries, 40% reduction in heavy goods vehicles, and 80% reduction in your light commercial vehicles, your utes, your vans, and 15% reduction through the concrete mix design and embodied carbon as well. So there's probably three key pillars of innovation in the construction sector at the moment. Starting off with digitization, BIM, you know, we can call it many different things. So this is something that Mace have developed in the UK, and it's developed in partnership with the Construction Innovation Hub. A Construction Innovation Hub is a UK government-led initiative, which brings together best practice and thought pieces and that sort of stuff. So effectively, what we're trying to do here is increase the standardization of our buildings and at the same time increase the digitization of our design. And that can be done through, you know, specification maturity models where we're defining the maturity against the best practice. And then what we can do there, once we've defined the digitization and the standardization, we can produce a roadmap of how we can improve both those metrics in the client's brief. Like all good business models, it comes with a matrix. So obviously the idea here is that we're trying to take everyone from the bottom left and we're trying to push them up towards the top right of the screen. And that's through, you know, your standardization of your design, the repeatability of that design. And then also as well on the digital front, you know, moving from digital file based, which is probably where most people are at the moment, through to standardized formats where we can have machine readable and machine executable data. And that's where that would support this sort of autonomous design work, you know, the compliance checking and everything else. So as a quick case study, Ministry of Justice, Luton Court, Mace were engaged to effectively take the client's standardized brief and put it into a 3D model and embed all of the data that they had there into this model. So you can see here, they're scrolling through the room, they're clicking on the different pieces of furniture and the different components of that model, and then it's bringing up, you know, key pieces of information like URLs, specifications, all of that sort of thing. And then how that digital library, what does it sort of fix for us in the industry? So often waste of time interpreting client requirements, creating bespoke solutions to things that have probably had bespoke solutions created in the past. So the reuse and the standardization and the digitization saves time and money through directly using those for individual projects. We get far greater knowledge transfer across the projects, easier to interpret briefs. Similar with the specifications open to interpretation. If it's presented to you in the digital library, it removes that interpretation. The next two key points there, compliance checking. If we have data that can be read by machines, we can have automatic compliance checking. There's no need for someone to roll through reams of paper, reams of PDF data to understand if that submitted design is compliant with a brief. It can be done automatically if the data is structured in a correct way. And then importantly on the final piece, once we have all this great data that we've produced as a design team, as a construction team, what do we do with it afterwards? And if we, you know, again, structure it in such a way that the facilities management or the people charged with the facilities management can use it, it can then be used to review the performance of that building over its entire life cycle. So the next key pillar is the modern method of construction. You know, this is the technology that we, or the methods that we actually construct our buildings. this slide here, I think when we talk about modern methods of construction, then people think about, you know, finished boxes on the back of trucks. I think it's important that it's not just finished boxes on the back of trucks. There are different types of prefabrication that we can go to, and ultimately they'll be right for individual projects. Some projects would support a volumetric delivery, some projects won't. And effectively what we're talking about on the left-hand side is probably the least amount of prefabrication, moving to your volumetric on the right-hand side, which is higher levels of prefabrication. But all we're talking about is how much do we do on a construction site versus how much we do in a factory. And we're tuning each individual component to make the most, get the highest productivity, the best safety, you know, all of those other factors that we spoke about earlier. So, you know, your standardized components are standard things that you buy directly from the suppliers. They're delivered directly to the site, but they're to your exact specifications. Your sub-assemblies are the components that go into your manufacturing line, where you buy the raw material, you construct it in a way that's suitable for your site, and then you deliver to site. And then, you know, volumetric, which is modular and volumetric. Those are the things that I think a lot of people are quite familiar with at the moment. So some worked examples of these. So, you know, we've got the structure and facade, which is a sub-assembly. Any Victorian people here will recognize that potentially from Hickory. Mace and Hickory have a strategic relationship of how they share that type of technology. Kit of parts, standardized components for the cores, you know, bathroom pods. I think everyone knows bathroom pods. Volumetric utility cupboards, and then some sub-assemblies for the horizontal services and the riser modules. So working back to N06, the project that we mentioned at the start, this was the 4D plan that Mace produced for that building at the time. And what you can see here is a construction sequence. You can see the slabs getting dropped in just beforehand. We had the horizontal services components that were going down the corridors. Now you see the facade and the slab sub-assemblies being bolted into place. And flying in a second will be the kit of parts component for the cores. Vertical sub-assemblies for the risers. Kit of parts approach for the core components. And then finally, we should have the volumetric bathroom pods that get dropped in shortly after that. So that's how they planned it in 4D. And then moving on to the next slide, this is what they actually produced or what they actually did in real life. So this project here was something called the Mace Jump Factory. It was a big tent on top of a building that would jump up the building and create that sort of weatherproof enclosure. This was the project called N08, which preceded N06, which is the project we've been speaking about. And so for N06, they got rid of the jump factory. Logistically, it was too challenging. And they replaced effectively the jump factory with this facade and slab sub-assembly, which again is that similar to that Hickory tech, if anyone's seen it in Melbourne going up. And then effectively N06 resulted in a further 10% improvement on the cycle time from N08. And so here we'll see the construction time lapse going through now. So you can see the sub-assemblies with the slabs and facades being dropped into place by the crane. And then you have your full floor plate and your full facade installed in 10 hours effectively. And then moving on through. These are your standardized core components. So your kit of part core components, all pre-cast. Backpropping for the floors above. You'll see the prefabricated columns going into place. Again, kit of parts columns, all made to specification to the same requirement. Small wet concrete pour for the wet joints between the slabs. This is where you've got those slabs and they have the horizontal riser components bolted in underneath. And effectively, when they're delivered on the truck, they're delivered on their back with the horizontal service modules underneath, and then they're flipped midair and then dropped onto site. And then you can see there, that's your sort of volumetric bathroom pods and also your utility cupboards. Finally, digital project control. And I won't go too hard into this, but once we've got all this data and well-structured data that we talked about earlier, you know, what can we do with it? And effectively, data collection and data environments is the next, what a lot of work is being done on. So you're effectively taking all of these data inputs, and then what you can do, take it into a data lake infrastructure. That's where a lot of the security functions are performed. A lot of the data is cleansed and organized. It can then be imported into a data factory, and then it can be pulled up via a means of display. And that could be headsets looking at a 3D model. It could be a projected, a control room with different KPIs for the project. But effectively, you're getting real-time data. I think in construction, there's always the monthly reporting cycle. This is real-time data. It's data reported, at the time, and it produces, the easier ways to make decisions on a project. I think with COVID, data and how we structure data is going to become all more important. If you look at the bottom center square there's a person walking around with that 360 camera doing progress shots. With COVID that we have nowadays, I'm sure everyone's probably struggling to get to site or can't get to site. As designers, if somebody could walk around with the 360 camera and take progress shots, and we can do our site inspections digitally, it's going to become something that's far more important. Similarly with your, site inspections, your pro formas, all of this data that can then be fed up into that sort of data warehouse and then assimilated. Looking at the right-hand side here as well, this is sort of digital command centers, something that project teams are starting to trial. This particular project is a Mace project in Ireland for a data center, and effectively just demonstrating real-time KPIs so that project team can make decisions in real time. And that could be anything from schedule, defects, RFIs, and assigning those tasks to the relevant team members and coming up with that. So that's it from me. I'll hand over to Neil now.
Thanks, Dan. Thank you. Thanks, everyone. Good pleasure to be here. And Dan's touched on a number of different things there in and around prefabrication. I'm going to dive a little bit more into the prefabrication of services. So I'm going to take you through a journey of prefabrication. First of all, we'll start out on my journey. I started out many years ago. It feels like almost 22 years ago. Started out in the UK. I work in hydronics. It's a nice name, but generally I started out as a plumber, working on a number of high-rise residential buildings in the UK. And then I had some great exposure working with the Wolseley Group in the UK into supply chain distribution, and also parts of some lean manufacturing through some of the suppliers that we were using on projects as well. And that then led me down into taking work off the building site. One of my biggest headaches was working on high-rise residential projects in and around the London area. And as many of you may know, sometimes those utility cupboards are in the hallway, and when you've got a number of trades trying to pass you and you're still welding, those trades can't get past through limitations and health and safety. So my first approach was to take, working on what today is commonly known as a utility cupboard or a hook, and basically build those within a factory environment and start bringing those to site. My background then started progressing further on into what else can be built and standardized off-site. Over the last 20 years, I've completed projects in Europe, Australia, New Zealand, Southern Asia, North America, and the Middle East. And there's a number of other projects that we assist people on, even though we are here in Australia. The method and approach that we take is almost identical. We have a set flow of processes to get the desired outcome for the projects. And like Dan said there, looking at project certainty, cost certainty. So the technologies are there. There are people that are building and doing prefabrication, but sometimes it's the knowledge, and that's what I kind of bring to the table is 20 years of lessons learned, sometimes 20 years of not always the right way of doing things, but it's learning from that and progressing through and looking at what we can standardize and productize. So that's led to us refining and having a set of robust practices through our lessons learned. And one of the things that my staff will attest to is I always say every day is a school day. Just because we send a module out today doesn't mean that that's how we're going to build that same module or a similar module tomorrow. We're looking at new technologies, improving our QA processes, what technologies can support us in tracking time, tracking what people have worked in what areas, tracking our reworks if there are any, and getting that data and taking it right the way back through our estimation. So we're learning all the time. We also learn off others. We have great affiliations and partnerships with other like-minded companies around the world. And because there's no encroachment, we do share a lot of IP and information, and even some of our insights and technologies that we've reviewed or we're currently doing R&D on, so that then, one company is picking that up and then another company can pick up another area that we're interested in, and we collaborate and we share that information. So prefabrication, especially in around building services, where did it all begin? This picture here is actually of the Lunt Fort in Coventry in the UK, where I was born and raised. And there's been a lot of architectural studies on this site. They've actually proved that there's prefabricated elements in this fort that was constructed around about 60 AD. And there are obviously, that wood hasn't lasted since 60 AD. There has been updates to it, but the original structure, it's traced back to 60 AD with materials coming from, at the time, Gaul, which is France. And that included prefabricated structures, posts, walling systems, because when the Romans were conquering other countries, they didn't know what materials they would have access to, and that they preferred to develop and then take those things with them. So were these the earliest bathroom pods? Interesting alternative to toilet paper there in the bottom, but these are things that the Romans did carry with them. So we could be looking at one of the very earliest bathroom pods there. Still better than some of the site toilets that I've visited over the years. So how do you start your journey? If you're not already doing prefabrication of building services or you're interested in it, one of the things we say is, and Sir Isaac Newton used this reference, and he didn't come up with it, he translated it, it's standing on the shoulders of giants. There are a number of people around the world, including myself, that have been doing this for best part of 20 years. And like I say, sometimes that is not always the right way of doing things, but we refine those processes and we get key knowledge and experience and insight. So it's nothing new. I would say the Australian market is, using the cricket analogy, slightly behind the run rate than other countries, but there is a keen attention to prefabrication here in Australia, and even more so now looking right into building services, which is fantastic to see. So, part of our organisation is to support people, support and share that knowledge. Knowledge is useless if you just contain it to yourself. So we have a number of people that we just support, and it might be an element of design engineering, and then building it is the easy part, or we go concept to completion. So that's one of the things that we've really refined. And our DFMA principles. Now, if you're not familiar with the term DFMA, it's an amalgamation of two practices, DFM and DFA. So design for manufacture and design for assembly. So the bringing of those together, DFMA, so design for manufacture and assembly, is a set of design principles and parameters and practices that have been proven through a number of different industries, not just in building services. But what we say is it doesn't just stop with building services at the MA part. We also have to look at things like logistics. We're limited by what we can transport or what is viable for transportation. The logistics and the installation on site can have a factor. And there's also a number of different items, like Dan mentioned earlier, about waste, about optimizing our waste. So are we optimizing the material that we're using? Are we optimizing our cutting of that material? Are we minimizing our waste? So there are a number of principles that go right from the very start of our design. There are new technologies such as design tools and machinery. We've recently invested in a rotary access laser. And if I show you on my camera here, this is a piece of 50 by 50 SHS with a number of different cuts that are basically fed through a rotary access laser machine. And we can pre-program this into our laser and pre-cut all those holes, those slots, and minimize things like hot works and welding or tack time. So we're looking at new technologies, but also new machinery, and looking into things like robotic welding, one to eliminate human errors, but also to eliminate health and safety issues. So there's a number of different ways of learning these technologies. But again, we like to leverage off the experiences of our counterparts in other countries, and finding out, you know, and not finding out the expensive way. An article here is showing a company in the UK, Crown House Technologies, beautiful orange boiler suits there. This article is showing these prefabricated multi-service modules being built for a project in the UK. And this article actually dates back to January 1996. So, you know, we are talking a considerable amount of time where, you know, horizontal prefabricated multi-service multi-service corridor modules were being used. It's not new technology. We are always advancing, and we're always supporting other people that are looking to advance in this area. So my key part here is start your journey now. You know, get involved now. There's a lot of information out there, and we're happy to share our knowledge and insight. So when it comes to prefabrication, there are a number of different things that fall under the realms of prefab. So we can look at, you know, just pipe work alone could be an element of prefabrication. Then we're going to go right to the other end of this scale, which is a fully prefabricated package plant room that literally gets dropped in place and is settled and pre-commissioned and very much a plug and play scenario. Within there, and Dan touched it on earlier, we have sub-assemblies. So we can look at integrating different services, so pulling together the mechanical, the electrical and the plumbing through these modules, or we might have individual components that are prefabricated. So there are different elements of this. Now, it's only through the early adoption in design and consideration that we can get to this greater end of the scale. It's very difficult when we get faced with a solution-based requirement very, very late in a project to try and then reverse engineer a riser or a plant if it's already been fully designed. If the consideration is there from the outset through the design process, it's a lot easier then if there are elements that still decide to go conventional or a prefabricated component or a sub-assembly rather than a complete assembly, it's a lot easier to manage that process. So this is really where DFMA comes from. And this is those design for manufacturing assembly and what's achievable and what's available in the local market and the ecosystem of suppliers here in Australia. Historical data. So, you know, this is a graph that changes across different industries. But here, when we look at building services, especially in the mechanical and plumbing space, where my background's from, but also the electrical modular wiring solution that we have, this is where the modular construction schedule can really, really change. So we're looking at that full 3D, again, DFMA, early integration of being able to BIM model and get approvals and permits and do that quantified materials early on, and then start building as site works and foundations are going on. So we are working in a factory while that construction is going on, and then we can meet that program. So once the building's topped out, we can then drop the risers into the shaft and start doing all our fit offs. So when we look at certain aspects of it, there is time saved of 30 to 50%. It can be 30 to 50% faster, but we can get in a total process around about 40 to 60% in time saving. which again, going through project cost and time certainty is invaluable to the construction industry. One of the other things I was asked to do, and we've done some posts on this on our LinkedIn page, is about myth busting. So some of the myths about prefabricated buildings or even some of our modules, the quality could be inferior to traditional building methods. Well, that's not necessarily true. When, for instance, we just delivered a massive riser module out of our facility yesterday. And when we transport these modules, especially large risers or plant skids, as they're transported to site, they do very much go through what we class as almost a seismic type event through that transportation. So we get a really good understanding of the tooling and the equipment that we use. A good example is we don't use tech screws to fix ductwork for transportation. We use a riveting system, and that's because it gives us a lot greater shear and tear than a tech screw because of transportation. And then there's also the seismic and structural component when it is in the riser shaft. So yeah, it costs us a little bit more in that material, but the time saving and the security and the quality just far outweighs it. Another myth as well is prefabrication and modular building services is actually de-skilling tradespeople. It's not. We have in our prefabrication facilities and other prefabrication facilities that we've assisted in setting up, we're working in a controlled environment. So what we do is we allow the trades to build and refine on the skills that they're trained to do. And we can also expose them to new innovative methods of building. So like I said before, robotic welding or rotary access lasers. The other thing is as well, which is a really big point, is trades on site can get distracted and get pulled away by having to take deliveries, by having to go and collect the materials from different floors, by moving materials around. In a factory controlled environment, we have people for those roles. So we allow those skilled labored people to focus on the skills that they've trained hard for. So that is definitely a myth busted. Another myth that we have is prefabrication is taking jobs away from these trades on site. It's not true. It really isn't true. Rather than taking jobs away, we're actually providing additional jobs to the construction and the labor force. Globally, for every 2 people that are retiring from the industry of construction, we're only seeing 1 person enter. Globally, there is a massive skill shortage. So the allocation of the trades and the works in a controlled environment is really, really key here. So we simply reallocate those workforces into those specific areas. We were able to then boost productivity. A typical trade is around about 4.2 hours productive on a site. In a production facility with the support that we're talking about is around about 7 hours productivity. So a massive variation there. So we can actually condense jobs. We can complete more jobs in a certain time frame. And in an era of where we're looking at large infrastructure projects, there's the Frankston Hospital, Footscray Hospital, there's a number of different infrastructure projects. You know, with skill shortages, this is one area where we can actually hone in and bring in on a lot of apprentices and really hone in on the skill set that's required for them to get through their training, rather than doing tasks on site like taking deliveries and sweeping the floor. They could be sat at a workbench for 8 hours a day for 5 days that week building valve sets. And that is what is part of their portfolio. And we get a number of different organizations and institutes come to us to help fulfill certain portfolios because they're not fulfilling that on sites. Prefabrication always saves you money. That's one of the things everyone angles towards. This varies. It very much varies on when prefabrication is adopted. So the early design stages, the use of material, how the installation is going to be quantified. You know, we try and provide that cost and time certainty, but sometimes prefabrication, like I mentioned earlier, is an afterthought or seen as a very late solution. So by reverse engineering, it can add additional costs because we basically redesign or going through the design process again to try and facilitate having a framing system in there. And then there's all the structural and seismic engineering that has to be done where things weren't previously considered. So the earlier adoption absolutely will save time and money. But if it is an afterthought or seen as a solution to health and safety, then that offsets it. You know, it might be cost neutral or cost slightly more. But what we don't have is in certain scenarios, we don't have people working in riser shafts, or we don't have people working at height, or we limit the amount of hot works on site. So it does vary. And people always ask for monetary amounts or percentages. It does vary from project to project, but we can give that information against conventional costing on a project by project basis. So the industry is turning to prefabrication for a number of different reasons. They're looking to reduce costs, eliminate those health and safety incidents, reducing site waste and storage is becoming an issue. We've spoke about the skilled labour shortages, and most importantly, you know, I've seen a number of awards given to projects, and when you review them, the projects have blown massively over time and massively over budget, but there are still awards issued out because most projects end up that way. And then we're looking at people looking for a quality assured 100% tested product. We've also seen recently the impact of lockdowns and pandemics. So because this time last year and now we're faced of a restriction of the amount of trades that can work on site, then this is where prefabrication in a controlled environment, people working on their own tool stations with their own tool setups, working in certain areas, can really work in the safely distanced controlled area, and we're able to isolate certain areas, we're able to stagger different lunges, and we're also able to coordinate trades as well. There are some downfalls currently in the Australian market. So there is when we look at multi-service or corridor modules, like in the image there, we've got electrical and containment. So getting other services to coordinate and collaborate together, because you know, we're putting those materials in, or a contractor wants to put those materials in. It can be seen as cutting someone's lunch, but you know, the time and cost saving and the engineering in and around this far outweighs that. And we are starting to see more and more collaboration between trades, and it's being driven by the builders, which is fantastic to see. Again, prefabrication can be seen as an afterthought or a forced issue. But one of the biggest things here in Australia is the industry, the knowledge and the experience, the standing on the shoulders of giants. And that's what we set up as. We are independent. We're not a mechanical contractor. We don't play in that space. We are there to support trades. And, you know, there is a lack of design for manufacturing and assembly because it comes from that industry experience and knowledge and those refined processes. And there are a number of technologies out and softwares out there that are massively underutilized. You know, we've worked on projects quite recently where there's no Revit model, you know, and then when there is a Revit model, it gets isolated for us to work on it. We'd rather work through collaboration tools and have a live document and be working in a live environment and a live collaboration. So there's transparency in what we're seeing, so our clients can see what we're doing, but also if there are any changes structurally or architecturally, we're working in that live environment. And most importantly as well, there is an issue with capability and resource. With people unable to travel internationally, we can't bring that resource in. So it's all about educating and empowering the people we have here in Australia. And there we are seeing a big uptake and more people wanting to know more and more about this, which is great to see. So what's happening today? You know, what is happening in the backyards of Australia? All these things here: plant rooms, risers, corridor modules, utility cupboards, bathroom pods, modular walling systems, medical health or substations, pre-assemblies. This is all happening. I've completed more than one of these here in Australia in the last couple of years. So it is happening, and we are encouraging more and more people to get involved and get that insight and move forward. I'm going to flick through a few photos now of some recent projects that we've completed. Prefabricated risers. This slide here, this is actually what left our facility yesterday. It was a 21-meter riser module. It was installed in less than 3 hours on site, and we only put 2 people on this job, and it took them 3.5 weeks to build the frame, to install the duct and pipe, and test it and send out the door. The equivalent of this would have probably took around about 4 to 6 weeks on site with about 4 to 6 people. So big difference. Now we could have put more people on it, but we have other projects running, and we wanted to see what our limitation of that capacity was. So this was really good exercise for us to see, you know, our capabilities and capacities with a reduced labour force, like we would have on site. Plant skids, now we can take these again from a fully plug in and play. Picture in the top right hand corner is, you know, fully commissioned, pre-commissioned VSD, switchboards, everything pre-wired and ready to go prior to going to site. Corridor modules, which we've talked about a number of times. And then there's modular wiring. So modular wiring is our electrical solution for power and lighting, and it is very much, as we class it, a plug and play system. So we have pre-wired switchboards as well. And then we look at things like pre-assemblies. So pre-assembling ductwork, VAVs, fan core units, fan skids, anything where we see that there's an opportunity to pre-assemble and send something to site and coordinate it. We've done a lot of things in and around fan core units where, you know, we've pre-piped them, pre-commissioned them, you know, wired them into the isolator and had them on a framing system with a tray, gone to site, and then all they have to be is lifted and fitted off. So we minimize the amount of components going to site and the errors that can happen on site, and then go through all this process. Utility cupboards is something that's been brought up earlier, especially in the laundry space. These utility cupboards are used massively in the UK. And we all know in high-rise residential areas, you know, prime real estate, if I stay in the service department, I open up the wardrobe and there's the consumer unit and the NBN and the alarm system taking up real estate in the wardrobe or above the fridge. And what we look at, and when you open up the laundry, there's massive voids in the overhead space. So we're looking at utility cupboards in that laundry space and modern pods. Modular serviced walls is another area as an alternative to bathroom pods. Bathroom pods aren't always accepted in some states because of the final sign-off by the contractor, the plumber, when he receives a bathroom pod. We have seen some of those issues. And then we look at things like medical head walls and head walling systems. So, you know, these systems are fitted to the front of a hospital wall, given a lifespan and a warranty of a time period of between 20 and 25 years, depending on the stipulation. But if we need then to go and change the purpose of that wall in that top right-hand corner, then it's a matter of replacing those panels and reconnecting the services that are already pre-made. So we can cut down that time from first installation, but also if we need to make change of use for that area or that ward, or later on do a refit, we're not going back to shell and core. We do have a number of case studies available covering hospitals, data centers, containerized data centers that we've worked on, showing a lot of the hours and the time saved on some of these projects. Some of the UK, Elephant and Castle was a massive site, but also the London 2012 Olympics through different volumetric builds, but also risers, modules, and plant skids as well. So I'd just like to thank everyone for my time. If you've got any questions, put them in the Q&A section, and I will stop sharing and hand back to the lovely team. Thank you.
Thank you, Neil. I'll just share my screen again. Move this over here. I've got some questions that have come in. So thanks, Neil, for the questions. Well, thanks for the presentation, both to Dan and Neil. The first question I have tonight is from Tarek. From a design, and this is to Neil, from a design perspective, is dfma prefabrication design exclusive to multidiscipline design firms where all services are designed by the same integrated team, MEP designers, or is there still a place for smaller design firms to contribute when every discipline, i.e. electrical, mechanical, hydraulics, is designed by a different company? And that question was to Neil.
Yeah, so from that design perspective in DFMA, there are a number of different things when it comes to integrating. Sorry, I'll start my video up as well. There are a number of aspects then when you're looking at smaller firms to try and contribute. Again, it becomes in and around the collaboration from the design consultancy firm, but also the architects and the involvement from that aspect as well. So there are a number of parties that can play with that, play a pivotal role in that early integration. And then having those multiple discipline firms, if it's a prerequisite from the architect or the builder themselves and they want to look at prefabrication, we do work with a number of design consultancy firms, and we help them with those parameters to say, hey, look, this is what's in place, this is what the view of the job is, and then we assist those design parameters. So then when it goes out to tender, a lot of those considerations are starting to roll through now. I hope that helps.
That's actually quite a good answer. I was actually thinking in my head, you know, in Victoria we have, you know, under the VDAS digital champions or DE champions. In some ways you need to call in a prefabrication champion, maybe.
Absolutely.
Maybe it's a prefabrication consultant that comes in over the top and coordinates and helps in that respect.
There are a number of builders actually that have brought in innovation managers or people that are looking towards like MMC or industrialized construction, as it's also known in the States. And obviously that is looking at push on not just technologies, but how they build and building smarter and building safer. So that's a prerequisite of their roles. And we're seeing that more and more within like some of the big design consultancy firms as well, which is fantastic to see.
I have another question, and it's once again to Neil, but Dan, feel free to chime in if you, you know, if you can add something there, and I'll chime in a little bit later because I noticed you had a presentation on Crown House technology, which is dear to my heart, because I used to work for Lang O'Rourke in the UK, so some of those images ring home. But look, how does DFMA impact on the scope responsibilities of the design engineer and contractor who sign off on the project? Quite a good question, and that's from Sean McKee.
Yeah, it is a great question because you know, the current method here in Australia is, you know, we look at D&C. So it's that movement of responsibility, and when we look at the D&C and D&C contracts, it's passing on that risk, and it's risk mitigation in theory. But we're working on a number of different projects. We're starting to see DFMA and prefabrication as part of the specification and as part of the tender. So there has to be inclusions in there, not just for like we've seen in there value engineer, but now we're looking at, again, smarter prefabricated methods and how are you going to do this in this time frame. A great example of that at the moment would probably be you know, the buzzword at the moment, the Australian Quarantine Centre. You know, they're expecting 500 beds by the end of this year and another 500 by the end of February. How is that going to happen? Now, the first thing they've done is gone, right, it's got to be modular, it's got to be prefabricated. And there's been a real big push in there. But everybody who's responsible in that project for the DFMA and the design principles in picking up those responsibilities. But it's got to be transitioned through the tender processes, and it's got to be specified in that. So there's big changes in contracts, big changes in tender specifications, but it is slowly but surely happening.
Another question open to both is, can we do this for underground stations? I think that
from my experience, yeah, because I spent a lot of time underground on Tottenham Court Road and King's Cross. So the answer to that is definitely yes. I've spent a lot of years underground. especially in around pipework systems in tunnels. So I would say yes from a services point of view. I don't know if Dan wants to chime in there as well.
Yeah, I think it's, I think ultimately the limiting factor, especially with those more bespoke projects, the limiting factor will probably be the logistics of what you're trying to do. So, if it's a big open cut underground station or something to that extent, there's no real limit on the logistics of what you can do in that space. I think it's, it's predominantly the logistics of it, but fully support what Neil said. Almost what we could get to now is a prefabrication study for each project that we do, which looks to optimize, that split between what do we do on a construction site and then what do we do, in a manufacturing area. And, I imagine a lot of projects would be slightly different to one another, but where we have those, social infrastructure projects like your schools, like your hospitals, there's a lot of repetition in there. So what we can do now is use standardized specifications and use those across the board.
I have another question. There's quite a few questions coming in, and I do welcome more questions from other participants, so please feel free to ask more questions. But there's a question here. There are a lot of prefab solutions to the new builds, greenfield projects. Are there any prefab innovations and or solutions in the industry for retrofit and rectification works?
Dan, do you want to take that one first?
And again, I hate to sound boring, but I think ultimately the logistics and the buildability of what we're trying to achieve is probably your limiting factor there. So if it's a refurbishment where you're stripping a large building down to its frame and reusing its concrete frame or its steel frame, the possibilities that we have there to drop vertical riser components down through those risers is really high. Similarly with the bathroom pods, we can use cantilevered decks to drop those onto and cut them around floor plates. If you're doing a small little refurbishment and you have 1 or 2 bathrooms to do, that price point that you would pay for the logistics of trying to get that bathroom pod in, you might have to take down part of a facade to get it in there. Or if it's a riser module, you might have to take off part of a roof. There'll become a point where that's just not economical to achieve. So I think it would very much depend on how much of this repeatable work, so you can optimize that manufacturing approach, are you going to do on that project, and then what are the logistics that surround that and the ease of installation.
Yeah, that's a really good point there. When you talk about logistics there, Dan, a great example would be we looked at a project in refitting an office building. There's a number of different toilet blocks, toilet facilities on each floor. So we looked at providing serviced wall systems for urinals and toilet cubicles as a panelized system. Now our limitation was the height, because everything was still going to be used in a lift. And what we looked at in developing was actually an extendable steel frame, so it could be transported and taken up in the lift, and then when it's in its final location, that final section could then just be like telescopic, taken up to the soffit and then fixed off that way. So again, and that's the beauty of DFMA. It's like, well, that was the design for manufacturing assembly, but then there's the logistics and the site movement and its final fit off. So it can be used, but again, it's that early integration and rectification solution, but also that cost comparison if it's viable. Oh, you're on mute, James, I think.
Yeah, sorry about that. I've got questions of my own, but I'll get to them later. The next question is from Tarek. From design perspective is, oh no, I'm going the wrong way through, it's sort of impact on scope responsibility. Yeah. Here we go. Why do you think that the adoption of plastics, this is a question from Ben Shepherd, why do you think the adoption of plastic materials over traditional metals within the building services market in Australia is negative when the use adoption in Europe is common practice?
It is an interesting question. I mean, when I first moved to Australia, one of my claims to fame was bringing copper press to Australia. I worked with TradeLink in introducing Vega to Australia, which was the first copper press fitting system. Now, a copper press is not a new technology in Europe, but it was certainly new to Australia 12 plus years ago. Now that was a metal on metal product, and Australia is very metal heavy. When we look at fusion and plastics, there has been a number of issues with certain supplies from overseas, and that has murked the waters with a lot of trades. PEX pipe is used more commonly now. Shark bite is a commonly used product here in Australia. But again, it's like that cricket analogy. It's the run rate, and other countries are using plastics a lot more than here in Australia. But that might change because we're seeing massive increases on the price of materials and price of metals. So it might be the force of adoption, and change of specification can force that requirement. But yeah, it is sometimes it's a slow one to break, because still now not everyone's completely convinced with copper press over 50 mil, because there has been issues in the past. So it's very, very difficult industry to crack.
And you don't see mat press over here so much as well. I used to use quite a lot of mat press in the UK. Stainless steel press pipe, same thing as the copper press Vega. You don't see that, maybe because the stainless is so expensive here. I don't know, importing it.
The same as a thin wall stainless system from Vitolic. You don't see that here. And thin wall stainless is massively used in the UK. There's a number of different things that could be used, but not even the use of Vitolic has its issues here in Australia. There's just some people that don't buy into it, and that can come from the design consultancy very, very early on.
Do you think there's the problem with the generic Vitolic breaking the quality there? Like we've seen the brand Vitolic, it's very good, stable product. But the coupler in particular, I've experienced myself in service, because I come from a triple P long service background, and when we investigate where we've had failures, it's always usually a retro brand that's come from another country, and whilst the QA might have been great one day, it might have slipped, and so you get this diminished quality of the product because you let it in, you got used to using it, and then someone along the supply chain decided to switch the brand and you didn't notice, and when you look up and you go, oh, it's weeping, it's you find it's not a Vitolic brand. I've found that to be quite challenging in Australia. Substitution, product substitution.
QS is obviously used a lot in the UK, going around and checking everything to the specification. One of my experiences with Vitolic has not always necessarily been the coupling, it's in around the quality of the pipe.
Roll joint,
when it's actually roll grooved, the thickness of the pipe, and the quality of the pipe from its source, and then the certification of the pipe and everything else as well. They have faced the same issues in the UK with different qualities of pipe, and there are stipulations, like someone mentioned about working on the underground. They would only use tartar steel on the underground in the UK because of it was a controlled quality and it was certified. But sometimes if you get subcontracted and subcontracted, you go down the tunnel, you're not always finding tartar steel pipe because people have swapped out to try and make more money because they've been pushed on the project. So it's really, really difficult to go through every fitting and every piece of pipe to ensure.
And that's not generally a prefab issue. That's just
that's not a
US quality issue.
That's the thing with prefabrication. With any certification, it gets assigned to that module. The pipe work, the fittings, everything that's used, it's quantified and it's visible. But it's managed and tracked all the way through. So we get free issued a lot of equipment. Now that's great, because we're not paying for it, but we hold it here. Now it could be $1 million worth of equipment here that's free issued to us for us to build. One, from an insurance perspective, we have to protect it, but two, once we sign for it and deliver it, we're responsible for it. So we have to ensure, you know, why it's delivered, it's to standard, it's, you know, it's not been damaged during transportation. But more importantly, it meets the specification, because as we turn it into a plant skid or a module, it then goes to site and it has to meet the specification. So, you know, that's one thing. That control is far greater, you know, in a facility like this, because we have a dedicated store person that's their function of their role. On sites, anyone can take the deliveries and chuck that pallet over there, mate. We'll get to that later. You know, that's the issues that we face.
Are there any emerging technologies, innovations that you guys are quite excited about? That's a question from Scott.
The thing, I think, something called platform DFMA or PDFMA. I think that's a really exciting sort of emerging approach to DFMA. So I think Neil spoke earlier about, you know, the sort of basic principles that sit behind DFMA. PDFMA is effectively looking at, you know, how many times have we all had, you know, or you know, had to design a disabled bathroom. So the Construction Innovation Hub, which I'll put a link on the slide I put up there, one big thing that they're sort of embarking on at the moment is this cross-government study about how many people have standardized design specification for disabled toilets, and that's just in government. And what they're finding is the Justice Department, you know, the police, etc., have their own design guidelines for disabled toilets. Ultimately, it's there to serve exactly the same sort of approach. And so the idea is trying to harmonize that design, that digital library for those spaces, and then that be used across sort of industry. And you know, I live in New South Wales, so schools infrastructure, New South Wales are very much trying to push along with their prefabrication and DFMA space. And you know, there's huge synergies there, that if schools infrastructure, say, linked up with, you know, health infrastructure, aligned their planning grids, aligned some of their other components, they can share all of these sub-assemblies. So, you know, you could have the frame and the facade of these buildings could be identical. That makes a school, that makes a hospital. They're doing the same thing. They're keeping warmth or cold air in, and they're keeping, you know, the rain out. And then what they can do is have their sub branches of assemblies that would turn a space that would traditionally be a classroom into an operating theatre. And that platform DFMA stuff, I think, is quite exciting, especially on the social infrastructure front. We're always going to need our, you know, our Sydney Opera Houses or our state theatres, which are absolute shining lights, you know, inspirational pieces of inspirational buildings. But ultimately, we've got a lot of very functional buildings, even residential. You know, there's huge shortage of housing all over the globe. And how can we do those things smarter? And I think there's a lot of innovation that will probably happen in that space over the next sort of 5 to 10 years. IKEA
for construction.
Yeah, yeah. I mean, I've seen with Autodesk have obviously spent a lot of time and investment, and there's a person that's come on board there heading up industrialized construction of Amy Marks, who's known as the Queen of Prefab. And I was talking to her at a convention that's happening in the States this morning at 6 o'clock this morning. But Autodesk are, you know, working on a product which is called Autodesk Assemble. And that's very much literally taking it through the design stages through Revit, but then tracking, you know, that module as it's going through the production. So the frames being manufactured, the pipes being cut, and it's seeing where everything is in real time going through that manufacturing process. So you can see if you are tracking on, you know, you're getting your project certainty and your time certainty, but it's all through the model, and it's all working in a live environment. So it's not just designing it in, it's then tracking it from when it's then hitting the shop floor and going through manufacture, going to site, going through installation. You know, the use of QR codes, everyone's very, very familiar with QR codes now. You know, we can QR code a module, put all the tech data and everything that goes with it. That, you know, if it's a plant skid with all the pump details, who installed it, the tooling that was used, the collaboration certificates, welding certificates. Whereas if you turn up on a conventional site and go, who installed that? You might get pointed to half a dozen guys. So that control is there. But Autodesk are doing some fantastic things on the technology side. When it comes to manufacturing, you know, tooling and equipment, you know, we've looked at certain tools and picked it up and gone, how's a guy going to hold this, you know, on a frame? It's a great tool, but it weighs about 20 kilos. It's just not usable. Where we've seen other innovations through equipment, whether it's robotics or even doing things through 3D print to see how things turn out, or through AI, you know, those kind of technologies of being able to actually manufacture something in 3D printing it and having a play with it. Through our rotary access laser, like I showed you a piece of metal before, how we can have a look at pretty much jointing systems that are used in carpentry. So like, you know, biscuit joints, all those kind of things, and saying, well, hang on a minute, when you make a set of drawers, they've got this kind of connection system. Can we use that in a framing system, and then have it rated, you know, for certain weight tolerances, so, and stresses. So there's loads of things going on. It is really exciting.
There's a question here from Kevin. What level of detail of BIM do you think is required to design for DFMA? And are you seeing a lot of LOD 500 specifications when it goes DFMA?
I'll let you answer that one, Neil. That's definitely in your court.
One of the big eye openers for me, and Dan actually mentioned this earlier on when we had a catch up, is in the UK there was levels of BIM level 2 and standards of design, and obviously, and government incentivized, you know, people get into a standard and being a standard of design, and you would only get onto a government project if you design to that standard and that level. And that's really driven it. Now we're starting to see more and more development in LOD, which is fantastic. Suppliers are investing more into getting their products, you know, put into things like Revit families, because they see the true benefit of it, because they want to get in. You know, if you want to get in, you've got to get in early in design. LOD is obviously 500 is, you know, is right up there. We don't design to that standard right now. If I'd be lying if I said we wouldn't, we're not working towards it. We are, but you know, we're more in the 300s than 350s than 500 currently. But it's definitely something we'd love to get towards.
Do you find, I mean, it's interesting because, you know, when you're designing for manufacture and you're talking about all your parameters, QA information, etc., being available, you're one step away from ticking the box to moving towards a 500 with controlled LOI, level of information.
Yes.
Maybe that's just people aren't aware that the information's already been done for the prefab. So I used to chant, don't bin the BIM.
Yeah.
And maybe that's an example where when there's prefab around, people haven't been aware that they've done all this great effort and they just bin it. There's not an end operator in sight.
Yeah. We use an expression, we don't source sawdust. You know, if we've created it, then that's what we use, and then we're moving it forward.
Good analogy.
Yeah, so this is a big thing for us.
Yeah,
there are other libraries like BIM-MEP, but you know, some of the level of details or even the information is not there from suppliers. So you're working with the information that you provided.
That's a big difference in the UK and here, is that we don't have that government library file for suppliers, the repository. I think that's a big thing that's positive in the UK that's missing here nationally. You know, Reece have digitised hydraulics, plumbing gear, but you request it and that's just one, you know, wholesaler. Whereas in the UK, it's a mandated process for government. I mean, it's a very big difference.
Absolutely.
And that would have a big impact on, you know, modelling. Why would you model with a generic image if you can model with a Grundfos pump day one?
Yeah, absolutely. Yeah.
Do you see that as well, Dan? From a time and saving UK versus here, like the repatriation of modelled information, especially between the services design team and then bin and then start again with the services D&C.
Well, I think, you know, and again, you know, the way I wanted to kind of structure the presentation to a certain extent to almost go through the narrative of, you know, what's early, and it's the digitization of the construction industry, and then we move into MMC. I think a lot of the time the attitude, and you know, I work as a client-side project manager, a lot of the time the attitude is, well, prefabrication is the contractor's job. You know, they'll improve their margins if they do it and everything else. I think, you know, the earlier you can adopt, and there's some questions in the chat as well, actually, that kind of talk about this. You know, that early adoption of dfma, and you know, how are we going to approach BIM? How are we going to approach collaboration and the integration and federation of models, and that sort of stuff is, and you know, absolutely key into achieving a good MMC delivery. Because otherwise, you know, and I've had this conversation with clients multiple times where, you know, they'll take a design up to schematic design or something like that, give it to a prefabricated contractor and say, I want that building prefabricated, but no one's approached the design to be prefabricated. And they'll, you know, say they give it to a volumetric supplier. You know, volumetric or modular construction likes not too long spans, and it likes quite low ceiling heights because it has to fit on the back of a truck. So what they'll do is they'll take your schematic design, they'll tear half the pages up, and they'll redevelop it. And you know, I think a lot of the time people are, you know, when we talk about MMC, they're always talking about what's the efficiency in construction, what's the efficiency here. But ultimately, if you've traditionally designed your building from a blank piece of paper, given it to a volumetric supplier who's then ripped it up, started again, have we actually saved any time? Have we actually been more productive? And I think that's a really important point, that innovation doesn't just start at construction, it starts way earlier. You know, the standardization, the digitization of the industry. So that's personally what I think. And, you know, getting a joined up approach in that early stage, I think, is probably very difficult. You know, there could be more government input into this. You know, Neil, you spoke earlier about, you know, the UK mandating level 2 BIM back in 2016. Even, you know, we were talking earlier in our little catch up about New Zealand and how they're changing their consenting laws to try and promote more of a product mentality approach to our buildings, so you can get pre-certification on certain elements. So when you do go through your consenting, which, you know, planning effectively, you won't get reams of conditions about certain components because they're all pre-certified by the people there.
It's an interesting, in terms of efficiencies, you had an image of the prefabricated riser ductwork assembly.
Yep.
Have you ever seen it where that assembly then doesn't get inserted into a concrete core that's been prefabricated as well? Because I seem to think there could be an efficiency gain there if you're going to do a prefab. And coming to your point about access, Dan, just drop the whole thing in and then put speed panel, or have speed panel already arranged, and then just seal off around the floor plates. Have you ever seen that done or executed?
Yesterday.
Oh, there you go. Because I was just thinking about all that concrete you've just poured for a riser that really does nothing other than encase.
So the 21 meter riser module we delivered yesterday was for a 6-story commercial office building here in Victoria. And yeah, they basically had a precast panel for the riser. We dropped the riser in, obviously open 3 other sides. We brace it to the precast panel for structural and seismic compliance. And then, yeah, away you go, speed panel, guys. The penetrations are coming off on one side. So, you know, that was an ideal scenario. I've got a couple of other things. Imperial College in London, we did the same thing through the central core. I actually spoke with, I did a webinar for the ASA, which is the Australian Architects Society. And one of the things we were talking about there was construction in a post-pandemic world. And when it's like, well, we're still in a pandemic world, not a post-pandemic world. And one of the things that I highlighted there was, you know, and one of the things that was really interesting coming from the architects was the focus on services, because the design function has to change with buildings. You know, commercial buildings are never going to be the same again. You know, the amount of air changes, all these different aspects that were thought of before. And I kind of threw the architectural brick through the window, and I said, well, when building services are basically the heart, the lungs, the lifeblood of a building, why do we get such constricted spaces, you know, such small riser shafts, but such big demand, the demand is bigger than the support that we're given. Do you think that will now change in a post-pandemic world? And the general consensus was, yeah, we need to actually have more of a focus on it. I've done a number of data centers over the last couple of years, and I love doing data centers because building services take precedent over everything, because you've got to keep power to it and you've got to keep it cool, so services are a priority, the shell of the building and everything else. So they don't take as much consideration. The services are priorities. So I love doing data centers, but yeah, no, it's interesting to see from an architectural feedback that it's like, yeah, there needs to be a lot more consideration in and around how the services go in, but also the space for the services as well.
Well, it's I've just noticed the time's 7:22, so we've done a fairly lengthy session. We've had quite a few questions, and I thank everyone for the questions, and more importantly, I thank Dan Hogan and Neil for their time today in presenting. It's been a great turnout. We had over 32 participants turn up tonight. So that's a great turnout. Would be fantastic if we were all around the table afterwards, but it is what it is in a pandemic world. But I'd like to draw it to a close now. But thank you both, Dan, Neil, for your time tonight. It was well received. Yeah, thanks again, and we'll call it a night. Thank you very much for having me. No problem. And yourself, good to see. We'll see you all around, and more prefab to come.
Thank you, everyone. Stay safe, and thanks for having me. It's been a pleasure.
Cheers. Thank you.
See ya.
Bye.